Hello everyone. So in this segment, we are going to learn another traversal algorithm of a graph. Okay. So this is also another traversal algorithm, means we are going to traverse all the nodes from a graph. So last segment we talked about breadth first search algorithm. This is one strategy where we explore the nodes of the graph level by level. But in the depth first search algorithm, we start with a vertex. Okay, so we start with a vertex, means we start from a single node. Okay, we can refer that as a root, and we visit one of its neighbors and we go further deep until we reach a dead end. Okay, means here we are going to start from a node, and from that node we will keep going, okay, until we cannot go anymore. Okay, means when we're going to stop when we find a dead end, and from that point we're going to start doing the backtracking. Okay, so we'll do the backtracking and we'll look for that whether we can find an additional path to explore more node. Okay, all right, we'll see example, but here the strategy is different. Okay, we start from a node and we'll keep visiting one of its neighbors and we'll visit, actually we will start exploring the node in the we'll keep digging the node in more depth and depth. Okay, so we'll go further deep, we'll stop when we cannot go anymore. All right, and when we cannot go anymore, we are going to start doing the backtracking. So we do the backtrack and we'll look for whether we find more node. Okay, so in this strategy we are going to use stack instead of queue. Okay, so we're going to use stack. All right, so first actually we are going to show you example how a depth first traversal works in a tree. All right, so let's see how this is going to work. Let's see, in a tree all the traversal algorithm works from root. Okay, so in the depth first traversal we say that we start from the root and we explore the immediate neighbor, and from that neighbor we'll explore another neighbor. Okay, and that's why we are going to actually go as deep as possible. Okay, and we'll stop when we cannot go any more deep. For example, here first we are going to visit A. Now A has 3 children, B, D, and E. Okay, from A we can explore any one of them, B, D, or E, but we're going to randomly choose only one. Okay, so let's pick D. Let's pick B. All right. Now, after we pick B, we are going to see what are the children of B. Okay, so B has children C and D. I'm sorry. So B has children C and F. So from B, I can take the path either C or F, any one of them. So I'm going to randomly pick any one of them, C. Okay, so you can see that from A I'm going to go B, from B I'm going to C. Now from C I cannot go anymore, that's the dead end. Okay, now what I can do, I'm going to do the backtracking. By backtracking means I have reached C from B, so I'm going to go to B. Okay, and from this point I will look that whether I can traverse any other node. So I'll go to B, and from B I can see that I have actually one more path left, and I can visit F. There is one more node I can visit. Okay, so I'll visit F. So from F I cannot go anymore. Again, there is another dead end. All right, so from F I'll do the backtracking. I'll go to B. So I'll do the backtracking B, and I'll see that from here also I cannot visit any more node. All the nodes are already visited. Okay, so from here then again I will do another level of backtracking. I will go to A. So from A I will see, okay, is there any more nodes left that I can visit? I'll see that I still have D or E. Okay, from D or E I'm going to choose one node randomly. It can be any node, either D or E. So let's pick D. Okay. So again from D, it's a dead end. So I'll do the backtrack and I'll go to A and I'll see, do I have any more nodes that I can visit? So I have E here. I'm going to pick E. From E, I can go to G, backtrack, I mean dead end. So I'll do the backtrack. I'll go to E, nothing to visit. From E, I'll go to A, nothing to visit. And that is the root. And that will end my traversal. Okay, and you can see actually here the way I am traversing the nodes is different than BFS. Okay, here I will start from a node and I will actually keep going deeper and deeper. So whenever I will reach a dead end, I will stop there and I will do the backtracking. Okay, doing the backtracking, I will again look for whether I have any more path or any more nodes available to visit. Okay, let's do one more example. So let's just draw a tree. Okay, so A, all right. So this is the tree here. I'll start from A, okay? And here I will print the way I'm traversing the nodes, okay? So I'll start from A. I have visited A. So from A, A have two children. A has two children, B and C. Now I'm going to pick only one of them, okay? So I can choose any one of them. You can pick initially B or you can pick C. Okay, so you have two options. You are going to choose any one of them randomly. Okay, so let's pick B. Okay, so from B you have two options, D and D. You can choose one of them. Okay, randomly choose just one of them. Let's pick D. So D has two options, F and G. You can choose any one of them. Okay, let's choose F. Okay, now here I don't have any more option. I cannot go any more deeper. So that's my dead end. So from here, what I will do, I'll do the backtracking. So I'll go to D and I'll look for further option. Can I visit any more node? Okay. From D, I can see that here I have one more option, G. Okay, so I'll visit G. Okay. Now G is another dead end. All right. So I'll do the backtracking. I'll go to D. So D doesn't have any more children that I can visit. So another level of backtracking. I'll go to B. From B, I can see that E has not been visited yet. So I can actually visit E. All right. So again, another dead end. So I'll do the backtracking. I'll go to B. So B doesn't have any more children. So I'll go to A. Okay. Now from A, I can see that I have visited B, but I have one more node that I can visit, which is C. So I'm going to visit C. Okay. So from C, I have just one more node I can visit. So I'll visit H. So from H, I can see I have two options, K and G. Just pick any one of them randomly. Let's see, I'm picking K. Okay. So K, then another dead end. So I'll do the backtracking. I'll go to H. One more node I can visit. I'm going to visit G. Okay. Then another dead end. So I'll do the backtracking. I'll go to H. No more node to explore. So I'll do the another backtracking. C. C doesn't have any more node. I'll go to the A. Now A doesn't have any more node. Okay. And that will end my traversal. So here the order I'm traversing the node looks like this. And as from every node, you can randomly pick one of its children. Here actually the traversal, I mean the order of the traversal can be different. Okay. For example, after A, instead of B, you can pick C. Okay. From C, you are going to pick H. From H, you can pick either K or G. Okay, let's pick K. Then obviously we have to pick G. Okay, so this is another order. From G, we are going to do the backtracking, and then we are going to pick B. So from B, you can pick either D or E. Okay, any one of them. So let's pick E because last time we picked D after B. Okay, so that's just, I'm showing you just the order could be different in DFS. Okay, so after E, we are going to do the backtracking. We go to B and we will have another option D. Okay, from D, I can pick either F or G. Let's pick G and we'll do the backtracking, and then we are going to pick F. Okay, and from F, that will be dead end, and we will keep backtracking and we'll reach A, and we'll see that we don't have any more nodes left. Okay, so that's a completely different order, but it's possible in DFS traversal. Okay. All right, so in the next segment, we will see how we can run the DFS algorithm in graph.